So now we begin our discussion about section 1.2, applications of linear and rational equations. These are in essence word problems. You do want to follow these guidelines outlined in the problem solving strategy box, where you read the problem first of all carefully, determine what the problem is asking for, and assign variables to the unknown quantities. You're going to want to write a little statement such as, we're going to let x be equal to the whatever is the unknown, number of apples or miles, etc. Then I think it's really helpful, if at all possible, to make an appropriate figure or table if applicable. Label the given information and variables in the figure or table. We'll see several examples of this practice as we go through our examples. Number 3, we're going to write an equation that represents the verbal model. You need to know about some formulas from geometry, physics, finance, etc. Or sometimes you need to be a little bit creative in formulating the equation that will work with your particular problem to get that solved. Then you're going to solve the equation and then make sure that what you get for your solution is relevant in the context of the problem. Let's look at several examples. As we go through these examples, note that the ones we're doing in this lecture are different from the ones in the ebook, and those are different from the Try This problems. So you have several points of reference when you're working your problems here. The first type of problem we're going to be looking at are application problems involving just simple interest, okay? For simple interest, for a loan or an investment, that's based on how much money was invested, what the interest rate was being charged, and the time in years that that money is being invested or loaned, whatever it is. Okay, so this is the formula you need to know right here to solve these problems involving simple interest. The interest income earned is equal to the principal amount, or the initial investment, times the interest rate. Now make sure on that interest rate you write that 4% as its decimal equivalent. That's going to be very important. And notice that the time variable is the time in years. That's what it says right up here. Time is in years. So in this quick example down below, for 18 months, we have to convert that to years, and that's 1.5 years that goes in the problem. So the amount of interest that is earned on a $5,000 investment at 4% interest for 18 months, also known as a year and a half, is the product of these numbers. Principal times rate times time. That comes out to be $300. Okay, let's look at our example on the next page. This says Laura borrowed a total of $22,000 from 2 different banks to start a business. One bank charged the equivalent of 4% simple interest, and the other charged 5.5% interest. If the total interest after 1 year was $910, determine the amount borrowed from each bank. Okay, we know that on her $22,000 amount that she borrowed, she earned, or actually she had to pay interest of $910. So in essence, one model that we might have to show this problem is the interest that she had to pay on the 4% account added to the interest that she had to pay on the 5.5% account. Notice that I'm changing these to decimals, is going to add up to be the $910. Okay? Now, remember from the previous discussion that interest is figured by computing the amount that was borrowed, the principal amount that was borrowed, times the interest rate times the time. Okay, now we know what the interest rate on each of these accounts was. We know that the time is 1 year. And so the question is, how do we know how that $22,000 was split up? Was it 11,000 and 11,000 equal splits? Was it 10 and 12? Was it 8 and 14,000, etc.? There's a number of ways we could split that up. So what we need to do first of all is write our little statement that shows what our variable is going to represent. Okay? We want to know what is the amount borrowed from each bank. So we're going to let X be equal to the amount borrowed from the first bank. Let's say at the first bank is the 4% interest. Now, if we know X amount was borrowed at 4%, then the remaining amount of the $22,000 was borrowed at the 5.5%. Okay? Now, if that happens, if X is borrowed at 4%, then, okay, the total $22,000 less the amount borrowed at 4%, that quantity there, that amount of money is going to be the amount borrowed at 5.5%. Okay? So here, down below, if interest is equal to principal times rate times time, we're going to put these amounts in for each of these quantities. Okay? Over here, the interest, which is again principal times rate times time. For the 5.5% account, that's going to add up to be $910. Notice I just carried down the plus sign from before. Okay? Now, the interest earned at 4%, we said that's the X amount, so we're going to put an X in here. The interest rate of the 4%, that's the 0.04 times the time in years. Recall from before, that is the 1 year. That's where I get the 1. Okay? Now, for our 5.5% account, the amount of money that was borrowed there is expressed by the total less the amount that was borrowed from the other bank at 4%, okay, times the interest rate of 0.055, that's 5.5% interest rate, and then the time here is 1 year. We need to clean up each of these quantities. X times 0.04 times 1 is 0.04x. Bring down the plus sign. Okay, here we essentially have 0.055 being multiplied by that quantity, right? And so 0.055, I gotta get a calculator here real quick. 0.055 times the 22,000, that is 1,210. Then we have minus 0.055 times x is 0.055x. And then times 1, right, of course, is just all that, equals 910. Okay, time to combine some like terms. When I take 0.04 minus 0.055 to combine those like terms for x, I have negative 0.015x plus 1210 equals the right-hand side of 910. Get me some more room here. Okay, now we're going to get constants on one side and variables on the other, so I subtract the constant of 1210 from both sides. And 910 minus 1210 is a negative 300. Okay, so on the left-hand side, I have the negative 0.015x. On the right-hand side, I have negative 300. Now to solve for x, divide both sides by the coefficient of x, negative 0.015. And so we get x, which recall from the statement above right here is the amount borrowed at 4%, okay, is going to be the negative 300 divided by the negative 0.015, and a negative divided by a negative turns out to be a positive, and when you divide those numbers, it's a 20,000, okay? So let's put a label on there. $20,000 is the amount invested at the 4%, or sorry, not amount invested, amount borrowed. And so what that means is 22,000 minus 20,000, also known as 2,000, is what is remaining to be borrowed at the 5.5%. And so we've answered the question that was being asked in the problem. Okay? Now, it's not a bad idea ever to go back and check your answers and make sure it makes sense. Let's see actually how much interest she had to pay off of borrowing $22,000 at 4% interest for 1 year. When you crunch that, 22,000 times 0.04 times 1, she had to pay $880, I'm going to write that right down here, in interest for this account. Here she borrowed the $2,000 at 5.5% for, again, a year. And so when you multiply 2,000 times 0.055 times 1, this number comes out to be 110. So you can see that 880 plus 110 does not come out to be 910. What in the world did we do here? Okay, let me try that again. I got to get a decent calculator to work on here. Stop. Oops, I see where I messed up in the checking of this. She didn't borrow 22,000. She only borrowed 20,000. That's what this number is right down here at 4%. My bad. Now when we multiply 20,000 times 4%, that's just 800. And the 800 plus the 110 is the 910. Okay, so again, be careful about your checking, but it should come out if you put the right number in there to begin with.